Okay. All right. So, yeah, so about a year and a half ago, I guess, was tasked with trying to integrate Asterisk with some of the, actually started with DeepGram and some of the text-to-speech services. So we were, I don't know if you were here last year, we did a brief presentation on using diarization in DeepGram to show how to break up different callers and color code, that kind of stuff. That has led down this road to try to interface with the Gen AI. Start just by saying that, as we know, thousands of entities already use Asterisk underneath your voice business log solutions, right? So, integrating with that is pretty nice. Asterisk, Josh has made this point multiple times already, but that it comes with tools like ARI, Snoop channels, and external media that let you build a non-telephony application on top of Asterisk. So interface with telephony to non-telephony. And what's nice about this, using this ARI model, is that there's very minimal changes to your existing infrastructure or your existing installations, all that kind of stuff. A call can move in and out of dial plan, into the app, out of the app. There's ARI is very minimal configuration. If anyone's here used it before, it's a couple lines to set it up. And then most importantly, you don't have to no C. You don't have to make any changes to Asterisk. Everything that we demoed yesterday, everything that's going to be demoed today, everything we're going to talk about today is using a standard version of Asterisk. Okay. So we'll start by, so there's multiple ways to bridge a channel into external media. This is the structure that we've sort of settled on, and we'll get into why. So let's see if my mouse works. Okay, so that's basically this top half of this top line is we should all be pretty familiar with, right? PSTN, incoming call via SIP, creates a user, you have a user channel, you put them in a call bridge with other services, other channels, and here they're all SIP, but this could be a local channel connected to whatever. But this is the general call model that we're used to seeing. The idea with this model is that you can sort of layer this on top of it without changing any of that. That works via audio hooks with the use of a Snoop channel. So with ARI, you can create something called a Snoop channel that lets you spy on and whisper into an existing channel. So we create one of those, we put it in a bridge with the external media channel, and that external media channel is what streams RTP to and from our application. So our application sits outside of Asterisk, uses ARI to build this call structure, and it uses Asterisk, the external media, to pull audio out of that, out of the system to the voice bot over RTP. I actually referenced, it's a little off the page, but did a blog post about this a couple of months ago. It's called Bridge Too Far. It goes into a little bit more how this works. Okay. Some notes about this model. If one of, not necessarily a downside, just the way audio hooks work, there have to be frames on the existing channel. So if you're not bridged with another caller and you're just talking to the bot and you want to still use this model, you need to play silence or something on that channel so that there's inherent framing. Will that change down the road? Maybe. And then, and when you're done, you can route it out of the application. Basically, the app can set some channel variables, pass it back to dial plan, call goes off to wherever it's supposed to go. Okay. Yeah, those are, like I said, use determine where to call. So in the example we're gonna, the demo at the end, basically the voice app chooses the IVR destination, sets some channel variables, sends it back to dial plan, and then in this case, we're just stubbing that off by playing a recording, but in theory, right, you can do anything else. Make a call out, connect that to whoever, your queue, whatever you have existing. Another important note, this is extremely important, that when you're using external media, it's a SIP-less call, but it still uses RTP. So a lot of these services you'll see don't use RTP, they don't have time streams, they're sending kind of blobs back and forth. So it's something you need to be aware of, that at least for now, Asterisk uses RTP for external media, right? What that means is that when the audio comes off, when your app receives the packets over that RTP stream, you've got to pull the header off, you've got to blob them together into suitable chunks to send to either your text-to-speech service or to your OpenAI service. In the background, in the backwards direction, anything that comes back in also then has to be unblobbed, framed, timed, create an actual RTP stream that you send back to Asterisk. But as it says, the last note here, check out the project update. We're looking at making improvements, enhancements, we'll say, to make that easier so you don't have to actually try to build an RTP stream. Cool. I put these sort of in here to have breakers at any point. We can kind of sprinkle in a little questions here and there as we go. If there are any questions about that call structure, are you guys familiar with Snoop channels? Anyone use any of that kind of technology currently? Yes, no, maybe a little bit. Okay.
If I can interject, because I have a mic. For those who may not be that familiar with ARI itself, Snoop channels are basically an advanced version of ChanSpy in the dial plan. It just gives more control over what's going on. That's also, and it's also built, ChanSpy is also built on audio hooks, which is why in ChanSpy, if you're whispering into a channel and that channel has no audio flowing, it doesn't work. They both suffer from that same problem.
All right, so, thank you, Josh. As Chris mentioned, if I had written this back in November instead of January, this whole section would have been different. Because back then we were working on a chat completions model, and it just sort of, there were a lot of challenges. So, once OpenAI put out their real-time APIs, it was really, I hate to use cliches or things like that. It made these things feasible. It went from being, yeah, it kind of works, to like, oh, this works. So you see real-time labeled in the API. A lot of products are called real-time, but what actually is real-time, right? It's largely subjective, right? What we're talking about is the user experience, right? Does the user detect any latency? Does the user detect any kind of lag, right? So it starts basically once you stop talking. If you're talking to somebody else, you stop talking, that timer starts in your head, whether you know it's there or not. And if you wait too long to process that breaks that conversational flow, right? And the user will start to, are you there? Like, did you hear me? Right, that kind of thing. And it gives you a miserable experience. On the other side though, if you flush it too frequently, right, the AI's handling the input linearly, and if you ask for responses too quickly or you give it too granular data, it's not going to come up with a very good answer. It's going to be less reliable the less information you give it. And then in the text-to-speech direction, you're going to have to, if you want the audio coming back to the user to sound like an actual person, you're going to have to chunk the text. Basically, you're going to have to assemble sentences for your text-to-speech engine to actually read. Because if you don't read it as actual full sentences, you just get the individual words with no nuance or inflection between the normal sentence structure. So you are going to have to do some kind of text chunking unless you really, really want to talk to a robot. So how do they do this? They work on basically all the ones that I've seen, both for speech services and for AI services. Basically they pre-process streaming information. So you send it the audio or the text as you go, and then when you're ready for it to send something back to you, you say, hey, time to respond. Okay, and if you think about it, that's sort of how we work as people, right? If I'm saying send it to you, we're having a conversation, you're thinking about what I'm saying, you're coming up with an answer, you're possibly changing that answer as my sentence changes and as I keep talking, and then when you determine that you've reached that socially acceptable time when you're supposed to respond, you respond. So these real-time services essentially model that sort of natural voice processing that we all use in our heads, hopefully. And we don't just blurt things out all the time. And again, the response, so we send it that way, we send it streaming, we send demarcation events to say, okay, I expect some kind of response from you. And that works basically in the other direction works exactly the same way. So whatever service, whatever bot that you're writing has the same responsibility. It has to receive interim results as it goes. And then once it determines that it received a demarcation event, it needs to take the next step. Okay. So if you're receiving audio, let's say you're talking directly to OpenAI, it's sending you this audio blob. It's going to send you an event that says, okay, I sent you the end of the audio blob, and now you know, okay, well, I'm done. I need to go on to the next step. And an important note, as I kind of mentioned before, and this is going to be a recurring theme of this conversation, this does not mean that the response is a time stream. It's not. And generally, and sort of it has to be, it's going to be, first of all, it's faster than real time, right? Because you've got to reassemble it and process it and play it back out. So if it was actually only coming to you as in real time, you wouldn't actually be able to layer any kind of processing on top of it. So the audio that comes back, the text that comes back is actually faster than human brain processing, and then we have to convert it to the audio or buffer the audio to play back to the user. Okay. So just a note about this presentation and the demo and all this kind of work. They're based on DeepGram and OpenAI, but the concepts generally for these models are universal. If you're using Whisper, if you're using any other competing services, API calls might not be the same, but the pattern is the same. Okay, so let's start talking about the DeepGram speech to text, which is the first step. Yeah, it generates real-time results with its own VAD modeling. So basically, we stream audio to DeepGram, and DeepGram both sends us back results and VAD events, voice activity detection for those. You generally will get a separate start event because knowing when the person started talking versus when you send them a result are two separate events. So you need to know when the person has started to respond. That can be to clear the buffer. If let's say it's talking and you know the AI is saying something wrong and you want to tell it shut up or to interrupt it, it needs to be able to hear you so that it can stop talking. So you need to know those events. This model, I didn't use the VAD events directly because I found that they were a little aggressive. And so basically if you said or ah or something like that while it was talking, it would stop talking, and people don't want that. So in this case, I think I used just sort of an interim result word count. So basically, if we see a couple of interim words come in on the fly, we know the person's actually talking versus making some kind of sounds, and we'll stop. Posted a link. I think this probably, will the slides go out? I don't know, links probably at some point. And then, so for VAD start, we get an explicit event. For VAD end, right, knowing when the person is done talking, DeepGram has this concept of endpointing and utterance end detection. You can sort of combine those different logics. Also looking at punctuation. Is this the end of a sentence, or is there a pause mid-sentence? You can kind of use those things together to determine when the person stops talking. So there's an explicit event for start talking. Stop talking is a little bit more implicit, and you sort of have to look at the results to actually determine that. And then in the backwards direction, the text-to-speech direction, as I mentioned, you're going to have to do some chunking. Basically, OpenAI is going to send you one word at a time. So you've got to go build that into phrases and sentences. And then once you have your phrases and sentences that form an actual thought, you can send that to DeepGram, and then the speech you'll get back will sound like a person actually talking. And then last part, the OpenAI real-time preview. So in this example, we are doing external text in VAD, and then basically it's going to spit back out text and functions. And functions isn't something we haven't talked about yet. That'll come at the end. But yeah, like I said, other services all basically use the same kind of modeling underneath. So whatever we talk about here should be analogous to everything else. So if we looked previously, we were looked at basically this, here's our little bot that was sitting in the corner, and here's Asterisk. And we didn't really talk about what it looks like inside the application. This is what it looks like inside the application. So we have there's a bit that's responsible for talking to Asterisk via ARI, okay? We have an RTP stream that comes from Asterisk to your speech-to-text provider. You then have a reverse RTP stream from your text-to-speech back to Asterisk. Those each are using a WebSocket connection to your voice services, so speech-to-text and text-to-speech. And then you have a language provider module, which connects over WebSocket to your language service. So in this case, this is OpenAI. This is DeepGram. This is DeepGram. And then the logic, that's your special sauce, right? That's what determines, that's the special part of this. The rest of it is relatively going to be common. How you, and Nad mentioned, the prompting engineering, this is sort of where that rubber meets the road. How you define that business logic that gets sent to OpenAI really determines how well this application is going to function. If you give it good, clear instructions with well-defined functions, you're going to get good IVR navigation. If you give it vagaries, you're going to get vague responses. It's really that simple. So, are there any questions on this page before we start looking at the different translation methods or anything like that? Oh, yep, okay. So I mentioned before, we're using DeepGram in this model, but you don't have to. Basically, with the OpenAI real-time preview, you can send audio directly to it, and it's, obviously it's far simpler, right? So if we look at that previous slide, we don't have any of this. These RTP streams are going to go right to the language provider, which is going to proxy them to OpenAI. OpenAI has, they've been very open that they're basically just using a local whisper model. They've said that it can use user inflection. Can it use user inflection? Don't know. The VAD events happen automatically. So when you create the connection to OpenAI, you set your VAD parameters, and it determines. So we talked before about knowing when the speech started and which speech stopped. If you're sending the audio directly to the AI, it's handling all that. You're not doing any part of that. Okay. It will send them back to you, right? So like DeepGram will send those VAD events, OpenAI will send you VAD events, and you have to do the same kind of things. Oh, the person started talking. I know how I have to take action based on the person started talking, stopping talking. Okay. Text is cheaper, as it says for now. When I first wrote this, using full text versus voice was about, I think it's 97% cheaper to use text instead of voice in this model. OpenAI has since reduced their prices significantly, so it's more like a 50 to 60% instead of a 97% savings, but it is still cheaper. If you are doing local text, you can do local text analysis and interception. What that means is that if I'm seeing the text before I send it to OpenAI, I have more control, right? I can look at that, I can intercept it. Is there a word I don't want to send to AI? Is there some kind of escape sequence or something that's happening? Bust out of it, and you can do that before sending it. In either case, even if you're sending audio to OpenAI, they do send back transcription results. So ultimately, you will have them, but you can't intercept it before you send it over. Additionally, because you're using something like DeepGram, where it's a dedicated text-to-speech service or speech-to-text service, there's more control. So you can specify word weighting, you can specify better models. There's a lot more to it, so you can finely tune it, the translations. Again, in this case, though, VAD does have to be done separately. So because OpenAI isn't determining it on its own when to send a response, you have to tell it when to send a response based on those VAD events. And then manual control of event generation is sort of a different way of sending the same thing, except for the fact that it gives you extra options. So if you determine the conversation basically has silence for too long, because you're manually sending the text, you could, in theory, resend some of the text or send another response initiation because you have control. And like it says, it requires a real-time speech-to-text component. So let's talk about, on the output side, talk about voice. Audio comes out faster than real-time, as you mentioned, so you've got to buffer it. Separate events indicate when it started and stopped. The VAD events, when you can specify to OpenAI to explicitly stop playing back audio when it determines voice, but if it's already sent you a buffer of audio, it can't unsend you the buffer audio, right? So you have to know, you as well have to know this person has started talking, so you need to take action as well. The biggest downside I found was actually integrating with existing announcements. So if, let's say, you're using a standard text-to-speech or text-to-speech engine, you can go ahead and create all of your canned and cached announcements using that engine ahead of time. so that when you're integrating with the AI, you can use the same voice and it all sounds like it's the same person talking to you the whole time. So the announcements don't become as obviously separate from the AI. Sometimes you want that, sometimes you don't. Again, much cheaper for now. Text to speech, you'll find if you start playing with this, is far more expensive than speech to text. It's almost more expensive than the AI itself. I think computationally, whatever models they have, it's more CPU intensive than text to speech. It's, that's relatively straightforward. Again, if you're not doing that again with OpenAI, you've got to do all that yourself. So again, you need to control all of that. This line is actually very important. The third blob here, where it says, at least DeepGram, at least the text to speech is configurable to aid pronouncement and proper word choice. I can't stress how important that is. So for instance, I have to explicitly tell DeepGram that if it gets the word free PBX, to break it into 2 words. And the reason I do that is because if I don't, then it says freaks instead of free PBX. So you need to have some of that baked in, right? Things like AGI. If it's not always going to know that 3 capital letters isn't a word, and it might go Aggie, right? So you want to have some sort of logic in your text processing that can handle these kind of things. And then the last point, when you set up your OpenAI WebSocket and you build the first connection, you determine what modes of output it can use. So if you tell it it can only send you text, you can still send it speech. So you can do speech in and then get text out and then translate that text yourself. So if you want to sort of run a hybrid and simplify it a little bit, you can. Cool. So now we're going to look at what sending and receiving audio looks like in practice. So whether or not we're sending audio directly to the AI service, we have to perform the same tasks. First is to pull the audio payload out of your RTP packet. You have to take those chunks and build them into segments suitable to sending to the AI. So generally your frame size for an RTP packet is going to be too small for what the AI wants, and it's going to want 2 or 3 of them squished together before you send it off. You have to make sure that you're sending those segments on a regular pace to the service, right, if you want regular results. And then you've got to listen for VAD and text results coming back. Again, the VAD events will come from your speech to text service, whether that's OpenAI, DeepGram, Whisper, whatever you want, that's what's going to do that. And the last point here, because I get this question a lot too, the stream from the application will almost always include silence unless we're doing VAD locally. So unless you're going to do silence detection on the box, either in Asterisk or in your application, you're going to be sending silence to your speech to text, and they expect that, and it doesn't bother them. They're doing the VAD for you. You have to think about it. I'm offloading this entire process to my speech to text service. I'm not doing any of this myself. Okay. If receiving audio, audio sent from OpenAI, DeepGram, any of the other services, it's not standardized. There's no standard method necessarily of receiving audio chunks over a WebSocket. OpenAI builds it into regularly spaced packets that are each, I think I said 10, essentially 10 times speed. So you essentially get 10, mu-law packets in one block and one WebSocket message. You have to take the audio out. It actually comes as, I think it's actually embedded in the JSON, so it's actually a field with a binary blob that you've got to do all the Endian fun stuff too. DeepGram actually just uses binary mode for the WebSocket, so the audio that comes back from DeepGram is just raw audio blobs. It's essentially a file. So the method of taking those blobs and building them into suitable chunks to put under your RTP engine are actually very different, because the way that the audio responses come back is very different. But they both send it faster than real time. They both send it faster than real time, and they both require buffering. So those are the 2 things you're not going to get away from. Again, there's no one size fits all. you're going to have to customize it to work with your speech provider. So if you swap it out for another one, there's some commonality with the eval events and the text results, but the actual interface is going to change. Each provider sends a different response done event. Those aren't common. And then the last line here, so deepgram requires manual flushing for demarcation. So if you're sending it text, remember I said you're sending it text on the fly, when you run a response back, you have to say, okay, give me a response back. I sent you enough text. So even if you send it a complete sentence, you then also have to tell it, hey, I just sent you a complete sentence. Give me a result back. And then the last part, which is the super most fun part of all of this, is that you will have to generate silence. So even though you're sending silence to your speech-to-text engines, the text-to-speech engines are not sending you silence back. So that's why that text-to-speech process is much more difficult than the speech-to-text process, because going from a nice, lovely timed stream to something else is very easy. Going from some random amount of audio to a nicely timed stream is much more difficult. You can, and early versions of this just took the audio blobs, put them in files, and just said Asterisk play back, right? You certainly can do that. But there are downsides to doing that, particularly with this call model. If you're in a simple bridge, maybe that's simpler and you don't care. But I think it was a goal, at least for me personally, for have this act like a real application and really send RTP back instead of using file playback. There's a lot of compromises in Asterisk that come with attaching a channel to file playback. Okay, so this is what that looks like, right? Our SIP call into the PSTN, we send RTP to the voice bot. The voice bot over a WebSocket connection sends audio, and it gets back audio, voice activity marks, and the functions. Sending text. So sending text segments is also fairly straightforward. We listen to local VAT events from our engine. So the way DeepGram works, a lot of these other ones work, it will send you interim results as it's sort of figuring out what you want, or what its results are good. And then when it's really, says, okay, these are the actual results, it's going to send you a final text segment. It says, mark it, says, this is final, this is my translation, here it is, this is good. So the other results, the interim results, can be useful for, like I said, knowing when the user's talking and for, intercept and stuff like that. But you don't want to send those interim results. You want to wait until you get the final results before you send them on. And then, as I kind of mentioned earlier, the response.create is what you send OpenAI that tells it to respond to you. So when you send, you could use speech final on its own. You can use the length of so I basically use all of these, right? So you look at the speech final indications to say this is valid text that I'm going to include. You look at the length of the overall amount of text that you've gotten so far, right? If there's no punctuation, but it's really long, maybe you want to send that, because that also means, the longer you wait to do that, the longer the person has to wait to actually hear the response. So you've got to look at the length of the amount of text you're given. You want to look at punctuation. Is it sending in a comma? Is it sending a period, exclamation point? Oh, that's a good demarcation event to flush to deepgram. And then lastly, deepgram endpointing events, which are basically periodic silence detection. If I've detected silence for a certain amount of time, combine all four of those, and you can get pretty responsive AI. Receiving text, you basically have to accumulate and forward those to the text-to-speech engine as it comes in to build your responses on the fly. And then when you get the response done events back from OpenAI, that's when you've got the end of it. And as it says here, that marks the end of the response, not when to start processing it. If you wait to get all that text and then get the response done and then send it to DeepGram, you've wasted the fact that you're a real-time service, right? You want to send those real-time results as you get them and then demarcate it when you're done. So you got to build, it comes as one or more punctuated words, build it into usable segments, and or forward. So you can do it kind of either way. You can stream them and then demarcate, or you can build it into segments, send, and demarcate. You can do it either way. You can build the sentences and send them over as a time. It's usually fast enough as long as it's just one sentence. Or like I said, you can send it in and then flush it. From there, you've got to build your RTP stream back to Asterisk, and that's it. You just keep doing this until you've got a function that terminates the call. And this is, again, the longer a segment that you spend to that text-to-speech engine, the more natural sounding the voice that you get back is going to be. But if you wait too long, you get more delay. So you've got to weigh those in practice between the two to see how that comes out. And here's what that model looks like. It's a little bit more complicated. So we have our call set up. We get our audio comes in. We send the audio to the speech-to-text service over WebSocket. That sends us back the text. We forward the text to the real-time AI service. We get a VAD event that demarcates the end of speech. We send that to real-time AI service. While this is happening, even before we tell it to send a response, it's doing that processing. We send a response. It's going to start streaming that text back to us. We stream the text to the real-time service. It sends us a response done. We forward that through to flush this out. And then we get that buffered audio gets played back over the RTP stream to your channel, to your call. So, up until this point, we've talked about how to actually get the audio in and out of the system, which is great and it's fun, but it doesn't do anything, right? You're just talking to a robot. It doesn't actually do anything. So to actually have it do something, you have to create a service. What's that look like? So I mentioned before functions. Functions are tools provided to the AI as part of the session to help guide it into building deterministic responses our application can use. Right? So you give it audio and text. That's your interface to the AI. And the AI tries to guide that conversation towards one of these functions. So the functions are sort of the wrapper of order around the chaos of the AI. So you have a non-deterministic conversation with the AI. I think I was going to mention in the last call or last presentation. Your conversation isn't scripted, right? You're not a robot. You're going to have a non-scripted conversation with the AI. The point of the AI is to drive you to the script, determine your intent from what it knows your possible intents are, and to get you there. Okay, and then functions can also include variables that may or may not have enumerated choices. So, for instance, if it's product support, you can enumerate a number of different products. If you want that to be passed back as part of your function, or you can just say product, but then you're kind of up to whatever the AI wants, right? So if you don't specify what the particular product lines are, you could say, I want help with my peanut butter sandwich, and it's going to put in peanut butter sandwich. Okay. Again, this was mentioned before. Giving good instructions to the AI is key. It's not just key, it's kind of everything. And you have to remember this is like essentially linear language processing, right? Like so if you give it a set of instructions, they say, if it's support, do this. If it's sales, do this. If you need to talk to an operator, do this. And then at the end you say, and then make sure that you confirm this with the user, okay? It's only going to confirm that with the user for the last one because it processed those steps linearly. Every once in a while it won't. Every once in a while it'll apply to all of them. So you have to be incredibly, you're talking to someone who has no nuance, who doesn't understand, metaphor. There's no metaphors with AI. You give it exact instructions. The instructions tell the AI who to be, not necessarily what to do. And I actually pulled this quote from OpenAI itself because this is my favorite quote of all AI, which says, basically, the instructions are not guaranteed to be followed by the model, but they provide guidance to the model on the desired behavior. What does that mean? It means whatever the heck you want it to mean. It means it's going to do what it's going to do, and hopefully it's what you want. And you can actually, this is a good use, right? I mean, these things like to talk to each other, and so if you want to use ChatGPT to write your AI prompts, that's not a terrible idea. It's actually pretty good at it. When it goes silent. So this is my favorite part, is basically you'll get to points where the AI isn't responding just because it doesn't think it has to. So you need to make sure that your application is aware of that and is looking at the timing of things. And if a certain amount of time has gone by and we haven't received any VAD events and we haven't received anything back from the AI, you need to do something, right? You need to either play a prompt, you need to either re-queue the AI, you need to tell it to do something so that the conversation can go on. Okay, so you need to monitor silence both on the AI side and the user side in order to determine when to reprompt the AI. And then, of course, have a backup plan, right? Send an update. Have a destination to send the person to if this isn't working. If for whatever reason this person isn't able to talk to your AI IVR, you need to be able to send them to somewhere that works for them. So you need to make that part of it. You can actually tell the AI explicitly and have one of your functions be, if the user is way too frustrated with you, send them here. And you can do that. Again, oversensitive VAD can be actually counterproductive. So if, I mentioned before that DeepGram is very, very sensitive, right? So if it's talking back to you and you go, and it just stops talking, and you don't know why, and you don't know what to do next. So you need to be aware of that. And you have to, like I said, so the compromise I came up with was basically a word count. I get the VAD start from DeepGram. We said, okay, we think they're starting to talk. And then, oh, we've got a word. Okay. Oh, we have a second word. Oh, they're definitely talking. Now we know, and we can flush that open and say, hey, they're talking. Stop. And then, again, about that whole non-deterministic part of it, right? Sometimes the AI will act like it's going to choose a function and then not. And you have to deal with that. So what that means is don't treat the audio or the text that you're sending to the AI as ephemeral. Hold on to it until you're done because you might have to resend some things if it stops responding. It's also very helpful for at the end if you want to build a transcription of your call, the voice between the AI and let's say you're gonna ultimately transfer this to a support person or a salesperson, passing that person the conversation that the caller had with the AI before they pick up the phone, extremely helpful, right? I worked in support for a decade. I would have loved to have a pop-up that said, hey, this is John calling and he's really upset about his SS7 cards. I would have loved that. Yeah, so another thing to do, this line here, you can do an initial response create at the beginning of your conversation. So if you don't want to have to prompt, so you can either play, when the user calls in, you still need some kind of prompting to get sent to the person to start the conversation, right? So you're either going to play back a pre-canned message or you're going to have the AI start talking. If you want the AI to just start the conversation on its own, before anything even happens, as soon as it connects and you send an update with its instructions, you can immediately send a response create, and it's going to prompt the person for what they want. And that's a very good way to determine if your instructions are good or not. Because if you put good instructions in and you pick up the phone and it says, hi, what do you need help with? Okay, it knows I'm looking for help, right? It's going on the right thing. This last bit, I haven't had this happen with OpenAI's real-time preview, but I have had it happen. Sometimes it will invent a function, which is very annoying. So you, like I said here, you might have a call contact, you might have a dial number, and it's going to come back and say, well, I think really what you wanted to do was a dial contact. Now, you don't have a dial contact function, but you should. And so here it is. Great, thank you. So when that happens, you need to either, figure out some way to determine what the heck it was actually saying, or you say, no, that's not an actual function, and you send it back and say, no, I need an actual response from you. Okay. That is kind of the end of it here. I will do a demo of the IVR that we built using this. Yeah, we'll try that out real quick. So this is just a simple three-leaf IVR, sales, support, or accounts. Basically, and if you call for sales, it wants to know if you're a new or existing customer. And if you are calling for support, it needs to know which product you are looking for. Now, in this, I explicitly did not fix the pronunciation of PBX because I want you to understand that this is something you're going to have to deal with. So let's give it a shot.
Please enter your password followed but a pound key.
Let's see if I can. Did I write down my?
You have dialed the wrong number.
Oh, I forgot my pins again. Hold on. I might have to look those up. Did I write it down? Hold on.
Please enter your password followed by the pound key.
Oh no, I forgot my pin. All right, I have to look up my pin real quick. While I look that up, are there any questions about anything from this presentation so far? Chris, can you facilitate while I look up my pins?
Any questions? Oh, here we go. Let me get over there.
Was it 5583? 68853? I thought it was 655.
Hello.
Made it too complicated. Go ahead.
Hi. Yeah, I saw you use an external media channel as opposed to like a traditional SIP channel. Is there an advantage to using an external media channel over, the traditional channel?
Yeah, so the big advantage of the external media is there's no SIP. So your application doesn't have to be a SIP client. It can just set up RTP streams and not have to deal with the overhead of the state of a SIP call.
Okay. Thank you.
No problem.
Next question. Okay.
All right, let's see if I can remember the pin.
All right.
Enter your password followed by the pound key.
Thank you for calling Sangoma. Please tell me how we can help you today.
Yeah, I need some help.
I apologize. It seems there was a break in the communication. Could you please tell me how we can assist you today?
Yeah, I need some support.
I can help with that. Could you please specify the product you need support with? It's PBX phones, cloud, or hardware?
Oh, it's with my phone. It's got a problem.
Hi, this is Samantha in support. How can I assist you?
So that was simulating the transfer to support. So once it determined my intent, it's transferred me over. That's actually another fun thing about the AI. A lot of times when it chooses a function, sometimes it'll tell you that it's done this like via text, right? So sometimes it'll send you text results saying, hey, okay, yeah, we're going to transfer you to here. Sometimes it doesn't. So you need to make sure that whatever function you have, can let the user know that they're being transferred, essentially, right? Let's try to mess with it a little.
Please enter your password followed by the pound key.
Thank you for calling Sangoma. Please tell me how we can help you today.
Yeah, I want to order a pizza.
It seems like you might have reached the wrong number. This is Sangoma Corporation. How can I assist you with our services today?
I need a good instructions for garlic bread. Can you give me some garlic bread instructions, please? I think we might have broken her. I think we broke her.
I'm sorry, but I can only assist with inquiries related to Sangoma Corporation.
Okay, fine. I need to speak with someone in accounts. Will she transfer me? We'll find out. Accounts, please. I think our pizza conversation broke her head a little bit. But yeah, so I mean, you can see you do have to have safeguards when you put in your prompt to make sure someone doesn't call in and try to order a pizza from your company because they're going to get really confused. Yeah, that's it. Anything else?
Any other questions? Oh, yep, over here. Okay.
When somebody calls, interrupt the AI, or do they have to wait till the AI finish talking?
So that's a slider essentially. You can choose. The deepgram, like I said, the VAT event is so sensitive that I didn't want to make it based on that, because if we make it based on that, as soon as I start making a sound, you'll stop hearing voice coming back. So that's something you can tweak. In this case, I wait until there's a certain number of words registered before I stop the playback.
Okay.
But you totally can.
Great. Any other questions? Oh, there we are.
Sorry, maybe this is too way ahead, but what about background noise? Filtering background noise, stuff like that.
So we use deepgram and DeepGram has very good background noise modeling, separation. So I've just been relying on them for that. One of the biggest issues you'll run into, and I can attest to this, is echo. So if you're testing this out, you want to make sure that you're either using a headset or like a real audio device that's got good echo cancellation, because otherwise the AI will just talk to itself and really confuse itself, which can be fun, but not helpful.
Great question. Anybody else? All right. Seeing none, thanks a lot, Mike.
Cool, thank you.